How's it going, everybody? I'm this is the first day after break for a while, so I'm getting back in the swing of things. At the end of this video, we're going to be talking about simplifying rationals. So just as a reminder, a rational thing is a fraction. That's essentially what we call rationals. It's just stuff that looks like this. Remember when we were graphing these types of things? But in this case, we are just going to be simplifying. You'll find out much later that these will also help us graph things like holes and slant asymptotes and oblique asymptotes and different types of things that we will have with rational functions. So just reminding you, for simplifying fractions, we know that 6 over 10 would reduce to 3 over 5. Another way of looking at this, these both are multiples of 2. So essentially we have 3 times 2 over 5 times 2. When we have the multiplication here, we can divide out the 2's. So that 2 divided by 2 right there, that just makes 1. So we are left with 3 over 5. That's essentially what we're going to be doing today. See what we can multiply. So here, 9 I know is 3 times 3. 15 is 5 times 3. So it looks like they have a 3 in common. So I can divide this 3 out, because they make 1. And this is just 3 over 5 altogether, just like our last one. So essentially, what we're going to be doing is seeing what we can multiply to make the numerator, to make the denominator, and then seeing if something divides out. So our directions here are simplify each expression. So this is my expression. State any restrictions on the domain. So any restrictions, please remember that you cannot divide by 0. Now right there, 2 divided by 0. That is not possible. That's saying how many times does 0 go into 2? Well, it goes in an undefined number of times. So it doesn't actually divide to anything. So this restrictions on the domain part, we are looking for our vertical asymptotes, or when our denominator equals 0. That's what we're going to be looking for. So to find the restrictions, the easiest thing to do is, if we want our denominator not to equal 0, if we do not want to be dividing by 0, if we take it and we set it equal to 0, and now we solve, so I subtract 8, 4x equals negative 8, divide by 4, x equals negative 2. Now if I put negative 2 in for x, 4 times negative 2 is negative 8 plus 8 is 0. Hey, that would make the denominator 0. So what that means, x cannot be equal to negative 2. That is our restriction on the domain part. Now for actually simplifying this expression, easiest thing to do, just try to factor out what we can. In the top, in our numerator, we can divide out a 3, and then we are left with x plus 2. And our denominator, we can factor out a 4, and we are left with x plus 2. Well, hey, oh, look, those factors of x plus 2 divided by x plus 2 makes 1. So this factor, since it's all multiplication, that divides out and that makes 1. So what we're left with is just 3 over 4. So we just have 3 over 4. That's how we simplify that thing. Real quick, I forgot I was going to do this, so sorry. I'm going to just remind you guys about factoring real quick, how we can factor things. There's different things we can do. Don't forget, we can take out a common factor. So with these, they have a 3 in common. They also have an x in common. So I can factor out 3x, and this becomes 3x minus 1, such that if you were to multiply it back out, you would get back to where you started. Here I can factor out a 2, and I have x squared minus 9. Well, this will also factor on the inside here. This will factor into 2 times x plus 3 and x minus 3. This one here does not have any common factors, so I will go back to my old school, some people call this like double bubble factoring or something, I don't know, they just call it factoring. So what multiplies to be 12 adds to 8, it would be 6 and 2, so plus 6 plus 2. Same sort of idea here, there's no common factors, so I'll just see if I can factor it like we usually do. It would be plus 6 minus 3, such that it would multiply back out to give me what I started with. Sorry, you don't want to see that. All right, going back to our other one. Thank you. You guys are amazing. All right. So again, for any restrictions on the domain, it's where the domain would be equal to 0. So we know in this case, r cannot be equal to 2. So if I have 2 minus 2, 2 minus 2 is 0, so that would not work. So that's our restriction part. I'm going to be looking for that, just write off to the side, just write something cannot equal 2, or whatever number cannot equal whatever variable you have. So here, the only thing we can factor is in our numerator, so 2 times r minus 2 over r minus 2. Those factors are now the same. This divided by this, that makes 1 altogether. So we are just left with 2 in the end. Okay, they're not going to be always just down to a number. Sometimes they will be left with an expression themselves. So hint, hint, wink, wink, that will probably be something like this. So here, for stating any restrictions, first I'm going to take the denominator and say that the denominator cannot be equal to 0. Well, I know this denominator to help me solve, I can factor it. So that means x cannot be negative 6 and x cannot be 1 when I take out my solution. So those are the restrictions. Those are important. So now as far as simplifying this thing, I know the bottom factored, the denominator factors. Like such. So now, check it out, these factors are the same. So what those make, that same thing divided by itself is 1. So I essentially have 1 over x minus 1, and that is how my expression simplifies. Cool, moving on. The same thing, simplify and state any restrictions. Sometimes, to help yourself state the restrictions, it's easier to just factor the numerator and denominator as is. So if I factor these things, so it's x minus 10, x plus 3 in the numerator, over x minus plus 8 and 3. So now for the restrictions, I cannot set the denominator equal to 0. So what that means, these solutions down here of 8 and negative 3 cannot be equal to 0. So x cannot be 8 or negative 3. That's one way of doing the restrictions. And it also saves time because you're factoring at the same time. And you see that we have a common factor of x plus 3 over x plus 3. Those divide out to make 1. So we are left with x minus 10 over x minus 8. Hey-oh, happy day. Simplify the expression. Nothing else we can do. Oh yeah! Alright, moving on. So now with simplifying these, notice in the last ones, when we got to here, we factored this and we had essentially something times something. Another way I could have rewritten this was x minus 10 over x minus 8 times x plus 3 over x plus 3. And it means the exact same thing because you multiply fractions across. So you're going to start seeing something like that, especially in this one. That's probably why I talked about it. Where these, if I were to multiply them together, they would just combine into the same fraction. So if you really want to see that, I don't usually write this, but this is what it would be if you would like to see it. And then we could simplify that thing from there. We would see that x plus 3 divided by x plus 3 is 1. 3 over 12 reduces to 1 over 4. So we have 1 times x minus 6 over 4. That's what we should be left with. I see it in this step because I know this is all multiplication. So I know 3 divided by 3 would make 1. I know x plus 3 over x plus 3 would make 1. So I'm left with x minus 6 over 4. Same thing. Again, it doesn't really matter which way you want to do it. Both ways will get you the correct answer. This one is just a lot more work, taking the time to actually multiply it out. All right, moving on. Next thing you're going to see is division. I'm not going to worry about that right now. So with division, when we are dividing fractions, don't forget, you guys learned this back in like middle school or something, right? We're dividing fractions.
You flip the second and multiply.
Or something like that, right? But essentially, you do when you're dividing fractions. So if I rewrite this out, 1 over 3 divided by 6 over 7. I have fraction divided by fraction, right? Here's the big division sign. fraction divided by a fraction. That looks super ugly. So what mathematicians decided that we can do, and it's algebraically correct, if I multiply by what's called the reciprocal of the denominator, essentially you're just flipping the fraction, making it the reciprocal. If I just look at what I am multiplying my fraction by, my whole division sign, what I'm dividing it by, I am dividing by 7/6 over 7/6. These together would divide to make 1. So I'm essentially not changing any of the values. I'm multiplying this thing by 1, just to be like a super ugly 1. But what this allows us to do is I know 6 divided by 6 is 1, 7 divided by 7 is 1, so it gets rid of my denominator. That's the point of this thing. So now it's just a multiplication of fractions. You just multiply straight across. Super easy. Much easier than what we were doing, right? So you see the division of fractions. You can flip the second, take the reciprocal of the second fraction, and multiply the first by that. So this is useful when we come down to things like this. Where'd it go?
Yes!
Things like this. Because I'm dividing by 1 over x minus 10. So I'm going to keep the first fraction the exact same. So x minus 7 times x plus 8 over x plus 8 times x minus 10 times x minus 10 over 1 now. So notice I'm taking the reciprocal of what I'm dividing by, and I'm multiplying by the reciprocal. So if you noticed, x plus 8 divided by x plus 8 makes 1, same as it does in this step. X minus 10 over x minus 10 also makes 1, so those are gone. So the only thing I am left with is x minus 7 here. You can put it over 1, but anything divided by 1 is just itself, so why not just leave it as x minus 7? All right, moving on, and go a little bit faster. So now, same sort of idea. Now, notice this is a quadratic, so I'm going to go ahead and factor what I can first too. So if I factor out a 2b, I'm left with b minus 6 over b plus 5. So there's my first fraction. And then times now, I'm going to make the reciprocal of this, so b plus 5 over b minus 6. Now it's just looking for if anything divides out. B plus 5 divided by b plus 5, and b minus 6 divided by b minus 6. So the only thing I'm left with is 2b. Happy day. All right, moving on.
Moving on up to desire.
I don't know if that's what it is here or not. You probably don't even know that theme song anyways. I don't even remember what it was from. I don't know. I'm not even going to guess and make a fool of myself.
Make a mockery.
All right, looking on. Just simplifying this thing. So again, I would factor this. This is multiplication, so I'm not going to make the reciprocal or anything like that. I don't have to. It's just multiplying straight across. So the biggest thing I can do is just factor and help myself.
Hope you guys are having a good day. I hope something exciting happens. Like, happy birthday, George.
I'm going to have a George in my class at some time, and he's going to be like,
Whoa, how'd you know it's my birthday today, man?
I was looking into the future. All right, just factoring this thing. X minus 2 divided by x minus 2 makes 1. X minus 7 over x minus 7 makes 1. So I'm left with x plus 3 over x plus 2. That should not be a plus. That should be a minus. X minus 3 over x plus 2. There we go. That one's ugly. That one's pretty. We'll put a bow on it. Pretty little bow for a pretty little answer. All right, moving on. Same sort of idea. You want to simplify. Dividing by fractions. That means I'm going to flip the second and multiply. Take the reciprocal of the second fraction, multiply by that. So factor the first. So x minus 5, x minus 2 over x plus 6, x plus 2. And now I'm going to factor the denominator. So that would be x plus 12 and 2, 6 and 4. There we go. Oh boy.
Too early in the morning for this.
And now factor the numerator. It's now in our denominator. So x plus 3 and x minus 2. So now let's see what divides out. Looks like I have an x plus 6 and an x plus 6. X minus 2, x minus 2. I don't see anything else that factors out. So there's a few options. We can leave this as x minus 5 times x plus 4 over x plus 2 times x plus 3. You could also see this as the multiplied out version. Either way you want to write that, I am completely fine. Makes no difference to me in the world. You'll probably see me leave it like this because I'm lazy. It's just the way it is. All right, last one. So again, notice we are dividing. So if you want to circle that division sign, whatever, just make sure that you take the reciprocal of this fraction when we multiply. So I'm just going to go ahead and do that step first so I don't forget. X plus 8 over x minus 8, factoring the denominator, and then over x plus 8. And then factor this guy, so x plus 8, x plus 2, and x minus 8, x plus 2. A lot of stuff's going to go away. All right, x plus 2 divided by x plus 2 makes 1. X minus 8 over x minus 8 makes 1. X plus 8 over x plus 8 makes 1. So I am just left with x plus 8. And that's really all there is to it. We'll use this stuff later on to help us graph. If you're in Algebra 2, we're going to do that later in not geometry, pre-cal or trigonometry, whatever you have in your area. All right, I will see y'all soon.